Good afternoon, I'm Chase Callahan, and today I'm going to be giving you a quick tutorial on how to do question 5 on your FRQ on your mini AP test. I'm going to be giving you all the tools you need to complete the question on your own without explicitly solving it for you.
Done.
So, part A has to do with both speed and the acceleration vector. So, we're given this is the position vector, x of t, comma y of t. And the derivative of these is equal to the velocity vector. So we have for x, it's f of x, and for y is g of x. Actually, that should be g of t. Sorry, g of t, f of t and g of t. So in order to find the speed, all we have to do is take the square root of the velocity vector for x squared plus the velocity vector for y squared, so that it's kind of like Pythagorean theorem where we have the y and the x, and then that's the speed. So the next part of part A asks for the acceleration vector. This is pretty simple. In order to do this, all we have to do is take the derivative of the velocity vector to get the acceleration. So it's just going to be f prime of t, comma, g prime of t. So part B asks for slope, which is given by dy over dx. Unfortunately, we have two separate equations for both x and y. In order to find dy over dx, we simply have to set this equal to dy over dt over dx over dt. This is because if you think about it, if you multiply this, make this into a multiplication form of this division, it's looks like that. So these dt cancel out, and that equals dy over dx, which is slope. So part C asks for position. This is our position vector, but as you can see, we don't have any equations here. So to find position at any time t, we're going to have to integrate these integrals of the velocity vector. So for the x, we're going to have to integrate f of t to wherever you want, to 0, because we know that x of 0 equals c, so we're going to do a 0 goes to whatever t we want, dt, and then add c, because we're going from that c to the next x. And then for the y value, it's basically the same thing, t to 0, g of t instead, and then that's just going to be plus d, because we know that y of 0 is d. And that's all. So part D asks for distance traveled. In order to find distance, all we have to do is integrate speed. So think back to part A. We're going to take the integral t to 0 of speed, which we remember is dx over dt squared plus dy over dt squared dt. And it's as simple as that.
Action.
And with that, you should be able to solve question 5 of the FRQs on your mini AP test.